Lecture 3, Segment 1, Creating Isometric Sketches from Orthographic Sketches. For the last 2 weeks, we've done some with the hand sketching. We've gone from isometric to orthographic. This was our finished product. Well, now what I'd like to do is turn that around. Start with this and create the 3D view, the isometric. Again, good exercise for the brain. Let's do it real simply first. Let's just deal with straight line entities. We'll deal next week with the curvature because that's a little bit trickier. But let's go ahead and start figuring it out here for these straight lines, shall we? Not too hard. What you're going to need is some isometric sketching paper. Notice the isometric sketching paper has this series of diamond shapes, and we see an x-axis like this, a y-axis like this, and a z-axis like this. See them here? Boom, boom, boom. And that's called isometric sketching paper. A lot of drafting stores, graphic stores, anything that sells graphic arts would carry this. We give it to you as well in your course materials, and it's a PDF file called ISO paper. So if you had ortho paper, now you have ISO paper. Just like we did before, you can see I can fill out my title blocks, get those all started and going well, and then I'm ready to go. So let me zoom out here and see how would we go about transferring these 2D views to the 3D view. And we're going to start with a very similar process that we've used for the last 2 weeks. We'll start by figuring out the overall size. How big is this thing? And then what we're going to do is we're going to draw an isometric box that's going to contain the part. And then from there, we'll sketch what our actual part looks like. And you'll see that that process works real well. It's very easy. Most people enjoy going this way. They don't like doing the orthographic views very much, but they find that the isometric are a little bit more fun. You do have to be careful. Things do get there's a couple little tricky things we'll need to go over, and fortunately these parts help us see some of those, so I think you'll see them quick enough. And remember that you do have, for all these hand sketching parts, you do have the actual parts that you can load up, look at, and spin around at your leisure and make sure that you feel comfortable that you see what we're doing here. So I hope that'll help you reinforce what goes on here. All right, let's count out here. We know that this is what? What plane now? Better be able to shout it out. I want to hear you right through the computer. It's the XY view. All right, that's the front view. This is the right view, so that's better be the YZ view. And then this one up here better be the XZ. See, I'm doing it too. The XZ view, the top view. Therefore, this line right here is X, and I can count it out. 1, 2, 3, 4, 5, 6, 7, 8. Y is here. I can count that out. 6, and I need Z, which will either be this axis or this axis, and they both better be the same. And it turns out they are, and they're both of a length 8. So our size of our box, our isometric box, is 8 by 6 by 8. Let me get out of the way, as I want to do at this point, and let's go ahead and draw that box. And just as I've done before, I'm going to start it in a different color just so you see what I'm doing here. Let me pick a point where I think it'll all fit. And this is probably the hardest part, because you'll pick a point and then you'll march down in X and then suddenly you'll run out of paper. So you've got to make sure you have enough room. But I'll go here. All right? And I've just drawn a little corner there. Can you see that? And what I'm going to do is I'm just going to march that over 8 by 6 by 8. So I'll go over 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. And I'll go up 6. 1, 2, 3, 4, 5, 6. Okay? And I'll go up 6 here. 1, 2, 3, 4, 5, 6. And notice what I'm doing. I'm drawing these little triads to indicate where the corners are. And what do we know about this one? Well, it goes back 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 8. 4, 5, 6, 7, 8. And what I've done is I've drawn the corners of the 3 principal faces, the front face, the right face, the top. Some people at this point will actually go in and actually draw the entire face in. You can do that. I find it very confusing. Some people enjoy doing that. They'll actually draw lines across here. But you need to be ready to erase them later. So if you do that, draw these things very lightly so you can go over them with an eraser gently when you're done and finish them. Make it look nice. Okay, that being said, I now know that my entire solid is going to fit within this box. I've drawn the outlines of the box. I know everything's going to fit in there. So if I see a piece of geometry flying out over here someplace, I know I'm wrong. Okay, let's start with our front face. I see it's 6 high. It comes over 6. Now you have to be careful. You have to look at that line and say, gee, that's solid. What does that mean? Well, you go up here and you can see what it means. Because you see it comes over 6, and then it skews over 2 there. So we got to be real careful how we draw that. So let's look at that. We can draw this back edge all the way across. We know that's 6 high. And we know from this edge here, we know that we can go across 6 again. So we can go 1, 2, 3, 4, 5, 6. Then we need to be careful. See, we look up here, we look over here, we say, gee, that looks like it's coming up 2, like that. And then it goes up here, 3, and here over 3, like that. You see that? This L here, there it is. It's a little lopsided because it's 3 units here and it's 2 units here. Because what happens now is I see that things look like they angle over. You see this face over here? This little square on the right face is over here in the center. So we go over 3, 1, 2, 3, and it goes up 2, and over 2, and up 2, and over 2. And that's the only feature on this actual face, on the right face. And what's happening is between those 2 points, we can see that, in fact, that's what's happening. It angles in. So I can draw that in. And boy, if you're not used to this, this can be a little confusing. Now along the bottom, now we can go and finish this bottom piece because we can see that this back edge here runs the length of the part, so all 8. So I can draw it in. And I can see that again I come over 3 and then I connect in. And then what happens down here? Well, it drops 2 from this point and connects in. Now let's look at something here. Let me zoom back in a little bit. From this, it's very obvious that that's symmetric, isn't it? 3 by 2. Now, you can see that. This leg is 2, this leg is 3. So this line and this line are supposed to be the same length, but they're certainly not. Well, that's the trick of projection. See, the isometric paper, it's all built in. You just count the squares. It's still over 2 and 3. 2 and 3. You count the squares correctly, it'll work right. And I'm driving the autofocus crazy. But there you got it. A neat trick. Let's deal with this back piece in here. We can see that we go up 4 from this corner. And it looks like from our top that we go over 2 on either side. And then what happens? From here we can see that it goes down 2. And then goes down 1 more. And it's centered here. It goes over 1, down 1, over 2. And then this connects to this connects to that, just like that. Likewise, I can drop 2 here, like that, and then over 1, down 1, and draw my connecting line in. And there's my solid. Now take a look at what happened back here. This line was pretty easy, this surface, which I see right here. It comes down 2 and then down 1 over 1. So it comes down 2, down 1 over 1, boom, that point. And in fact, I'm missing a line right there. But over here on this side, I don't see any of that because the part's oriented such that I don't see it. I start to see it. See, I went over 1, then it wound up connecting here into this point. And that's the trick you do with the isometric. What you do is you keep drawing the geometries till you hit geometry you've run into before. And then you stop. You see, the remainder of this shape is hidden here. This part of the solid hides it. And we do not have X-ray vision in isometric sketching, so we just draw it as I've shown you here. This may take a little practice to get used to, but I think in time you will get used to it. What you need to do is just to start at a corner, like we did, work your way around, and then close it all up. And it's usually in the back and in the back corners where things will get a little goofy. Lines, you may only draw a portion of them before they disappear on you. Let me just pop back in. We'll wrap this up. So with isometric sketching, no hidden lines. And the way we get around that is we just keep drawing the geometry until it runs into geometry that we previously built. Start with the simple faces. Start with the stuff that exists on the principal faces of the box that you know you're going to see all of it. And then work your way in from those points to get the interior features. And you'll do fine. Take a week, practice this with the straight line problems, and then next week we'll really throw you for a curve, literally, by trying to deal with isometric circles. And that should be plenty. But in the meantime, when you're all set here, come on into the main part of the lecture. We'll continue to talk about engineering drawings, simple extruded solids, and that will be enough for the day. So we'll see you then.